All right, welcome back to our video lecture series on chapter 2.2 in the Lock 5 textbook. And in the last video, we finished looking at this slide and looking at this dot plot of world box office in 2011. And I mentioned this, but we had the average box office was about $150 million worldwide. But the median was much less. It was only $76 million worldwide. And so I started mentioning last time the reason for this discrepancy usually has to do with the extreme outliers, these extreme values over here. What these values do is they pull the average up. You're adding these numbers in. You add, the $1 billion for Harry Potter into the total sum and only divide by one more. So outliers are going to affect the average, the mean, a lot more than the median. The median just cuts the value in half. Is pulled in the direction of skewness. So I like to think with this, if this Harry Potter, instead of making $1 billion, made $2 billion worldwide, that would greatly affect the average. This would move up, but the median wouldn't change at all because this number still cuts the data set in half. So if a distribution is left skewed, which measure of center would you expect to be higher, the mean or the median? In this case, it'd be the median. The mean will be pulled down towards the skewness. If it's left skewed, that means there's a left tail. So the mean is going to be pulled towards the left values. So the mean would be less than the median in this case. Okay, I mentioned before, but an outlier is an observation that is notably distinct from the other values in the data set. This is a very kind of intuitive idea of an outlier. We will get to some formulas and be more precise about how we define outliers in a later chapter or later section in chapter 2. But right now, I want to just get the idea of what an outlier is. And if we go back to the world box office, mentioned before, but we have, I believe, 3 outliers. These 3 box office values, the 3 top grossing movies in 2011, Harry Potter, Transformers, Parts of the Caribbean, are a bit of a gap away from the rest of the movies, in that year. So we would say a statistic is resistant if it is relatively unaffected by extreme values. So what you saw on the previous graph is the median is resistant while the mean is not. And there's another example. If we, with Harry Potter in the previous data set, the average was 150 million. The median was 76 million. If you were to delete Harry Potter from the box office, the mean would drop by 9 million. Well, I guess about 9 million, whereas the median only drops 1 million. So that's what we mean by the median is resistant. It doesn't change as much. All right, when using statistics that are not resistant to outliers, we want to stop and think about whether the outlier is a mistake. If not, you have to decide whether the outlier is part of your population of interest or not. This depends on what you're studying, whether you want to include outliers or not. And usually for outliers that are not a mistake, it's best to run analysis twice, once with the outlier and once without, to see how much the outlier affects the result. I think if you're trying to study, human height, and you come across someone that says that they're, 7 foot 1 inches tall, that would definitely be an outlier, but that's reasonable. There are people that are 7 foot 1 inch tall, but they're a very, very small subset of the population. So that'd be an example where it'd be good to run the analysis twice, one with and one without the 7 foot tall person. Whereas if you're studying human height, but you have someone that's claiming or saying that they're 10 feet tall, that's not possible. The tallest person on the planet is 7 foot something, 7 foot 6 or 7. So if you have a 10 foot tall person, you would want to delete that outlier because that's not possible. Whereas if you're looking at income and someone says they're worth $20 billion, you want to stop and think, is that true or not? But it is possible. There are people that are worth that amount. Okay, in summary from this section, we visualize one quantitative variables with dot plots and histograms. Study the shape, looking at symmetry versus skewness. And we looked at 2 different measures of center, the mean, which is not resistant to outliers, and the median, which is resistant to outliers. All right, that concludes our video lecture series on 2.1.